Hello everyone, my name is Noribeth Mariscal, and today I will be going over my poster presentation titled Evaluations of Model Simulated Ozone and its Precursors in MUSICA-V0 against In-situ and Airborne Measurements over the continental United States. Anthropogenic air pollution has become an increasingly critical issue that affects air quality, climate change, and human health. Surface ozone is a secondary pollutant formed by the chemical interaction between high emissions of nitrogen oxides and reactive hydrocarbons in the presence of sunlight. The industrial and transportation sectors are both large emitters of ozone precursors and are highly contributing to its formation. Implementing MUSICA-V0 models to simulate surface ozone and its precursors will assist in better understanding the sources of ozone precursors and their relationships with ambient air quality. The objectives of this research project is to understand the causes of ozone production in affected regions and their impact on ambient air quality through high-resolution chemistry modeling, to investigate the sensitivity of model horizontal grid resolutions to atmospheric composition and chemistry, and to improve physical and chemical processes of atmospheric chemistry in CSM2. MUSICA-V0, or the Multi-Scale Infrastructure for Chemistry and Aerosols version 0, is a configuration of the CAM-CHEM Global Chemistry Climate Model. The model uses spectral element dynamical core, which is an unstructured grid mesh based on a cubed sphere, allowing for regional refinement. For a more in-depth description, you can reference Pfister et al., published in 2020. I employed MUSICA-V0 to look at summertime ozone and its precursors. I ran the model from May to August of 2014 using the default resolution, which is approximately 14 kilometers over the contiguous United States and approximately 1 degree or about 100 kilometers for the rest of the globe. I also sampled ozone and precursors along the flight tracks of FRAPPE and Discover-AQ. MUSICA-V0 output can be quite difficult to visualize because it uses an unstructured grid. For a model simulation using CAM6-CHEM with a standard grid, you would have an output structure that includes latitude and longitude dimensions when wanting to plot a specific point. In an unstructured grid, the output files have columns or dimensions without coordinates, which makes selecting a specific location for plotting particularly difficult. As someone with initially very little Python experience, the Jupyter Hub tool available through NCAR supercomputer Cheyenne really made the experience much easier. I initially began plotting mixing ratios across the continental US using a predefined module called Plot2D. I did run into various issues with memory and indexing on Jupyter Hub while attempting this for the first time, but the support I have received from NCAR scientists has been of great help. These are some of the initial plots that I plotted using the predefined module Plot2D. I have plotted the ozone concentrations over the United States for June, July, and August of 2014. I have currently been working on evaluating model simulations against the aircraft campaigns FRAPPE and Discover-AQ in Colorado. These campaigns were conducted simultaneously in the summer of 2014 over the northern Front Range metropolitan area around Denver. They were tasks with taking a look at different emission sources, chemical processes, mixing, and transport. The plot here simply shows the surface pressure over Colorado, especially outlining the Rocky Mountains. Some of the ongoing and future work that we're focusing on is improving physical and chemical processes associated with ozone atmospheric chemistry in CSM2, due to large biases between observations and simulations. With this in mind, we will employ both CAM6-CHEM and MUSICA-V0 with different model configurations to investigate ozone and its precursors from 2014 to 2015 and eventually extend to other periods such as those from 2010 to 2021. We intend to run a set of simulations to investigate the sensitivity of model simulated ozone and its precursors to bottom-up emission inventories as well. Model simulations will be validated against additional campaigns such as the recently NSF-funded Moose Field campaign over southeast Michigan and satellite observation data of tropospheric column density of nitrogen dioxide and formaldehyde from TropoMe and its sister sensor Tempo, set to launch in 2022. We aim to improve chemical mechanisms associated with nitrous acid in Cam 6 Chem and MUSICA-V0 with constraints from our Moose Field campaign. We also aim to refine a domain over Michigan with about 7 kilometers over Michigan, 14 kilometers over the surrounding areas, and 1 degree over the remainder of the continental United States. And I just want to give a special thanks to my advisor, Dr. Huang, and Drs. Louisa, Emmons, and Duseong from NCAR. This here is my contact information. If you have any questions, please feel free to reach out. And thank you so much for listening.